there guys, Mike here again. Thanks for clicking this video. Welcome to my shop. In this video I'm going to build a simple EL84 single-ended power amp. Now an EL84 tube here is a common tube, typically found in guitar amps, but they also make for a decent hi-fi stereo amp as well. So what I'm going to do is walk you through steps on how I incorporate this into a stereo amplifier. Building tube amps is a hobby of mine, and I do enjoy showing you guys what I build. I recently built the 6D N7 amp here, and I got a full build video of this. You guys seem to really like this, so I decided, well, let's see what else I can build for you guys. I did a poll on my community page. An EL84 amp is something that you'd want to see. So here we are. The EL84 amp is actually quite a common amplifier to build. There's lots of variations of the schematic you can find online. So what I ended up doing with mine here is I downloaded the spec sheet for EL84. It gives us operating parameters for some Class A amplifiers. I'm going to bias the tubes a little bit lower so I can get some longevity out of it. So it's going to be a two-stage amplifier. The input tube, we're going to be using a 12 AT7. Here's a twin triode tube, amplification factor or mu of 60. These are commonly found in guitar amplifiers and are readily available, which makes it good for tube rolling. And of course I bought a matched pair of JJ EL84s, commonly available and quite affordable. So for the power transformer, we're going to be using this Hammond 270DAZ. For the output transformer, we're going to be using these Edcore ones. So these are the XSE 10-85K. So these are a 10 watt output transformer. They have a 5K primary with an 8 ohm secondary. They're readily available, quite affordable, and they sound pretty good for the price. So those are the basic components I'm going to use. I did up a very rudimentary schematic here which I'm going to follow. Once everything is finalized and all the voltages check out, I'll do up a proper build document with a schematic and a parts list, and I'll link it below. And if you guys want to build something like this as well, you can. So let's get into the build here. I'm going to make a custom chassis out of steel. So this is 18 gauge steel. I went to my local metal store, gave them this piece of paper to shear up all the pieces for me, so the top and sides. Since I don't have a brake, I'll just put these together and I'll just weld them all up, grind them all down, and it will look like one seamless piece of metal. Now if you didn't want to go that route, you could do something like this. Get a piece of aluminum and put it onto a square box, and that would be used as a top plate. And I built several amplifiers like this as well, and it works well. And lay out the components here. Lucky for me, I had most of my components in my parts, but the only thing I really needed to purchase was the steel for the chassis and the transformers. So we're going to do this old school. We're going to use some cardboard and we're going to transfer the marks over to this, and then we can use this as a template. So the cardboard down, we're going to put the transformer near the back. We're going to have the incoming AC in the back wall. We'll have the fuse holder in the back wall. Put the output transformers down. We want to keep some separation from here, and we want to make sure that the actual laminations are perpendicular to each other, so there's no induction there. So probably around there. The power tubes in the back here, close to the output transformers. Keep the runs short. Input tube near the front here. We'll have a switch on the front here, and then we'll have an indicator light. We'll have our incoming RCAs near the front here to keep it away from any of the AC lines there. Keep these runs short. Another thing I'm going to include with this build is an actual line level or volume control. So I have a potentiometer here, a dual gang I'll mark up front. Typically in my amplifier builds I run them in a preamplifier, so this will just be used for adjusting for line level. But if I want to use this as a standalone system, I can, and I'll just use that as the volume control. Everything all laid out here, the front panel, the side panel, the grommet holes, and the rear panel there with the speaker connections and the AC. I have these chassis punches from Greenlee. They work well. I've had this for a long time. Harbor Freight actually also has a chassis punch set. For under $20 you can get a full punch set to do all your tube amp stuff. If not, these step bits works wonders as well, and these were big enough to do an 8-pin socket. So let's go ahead and punch and drill out all the holes. So those are the side panels all completed, and that's the transformer mount there. So I line drilled the opening there, and I'll finish it up with a file. And what's left to do is punch out the tube sockets. So you can see the punch here has these teeth, and the other side has this little socket. We'll push it through the hole and we will pull it through. Most of the metal fabrication is done here. And I got the rear transformer all cut out there. So what's left now is to do some welding. Well, everything's all tacked up here. Turned out pretty good. Everything's all nice and square. So we'll run some nice long beads all around the corners here. Careful not to warp anything. And once that's all done, we'll work on a front panel. Doing some more fabrication and mock-up here. Got the front panel done with a little bit of a view screen there, a shield. And then in the back here, I just loosely fit some of the components. I was going to put a little back panel in here, but I think I'm going to forget that and just go with some transformer covers. Well, the chassis fabrication is pretty much complete, so all I have to do is paint it now. Before I do that, I'm going to do some lettering. So I want to letter the front panel, the rear panel, and of course the tube socket. One thing I want to mention is make sure you use the same brand paint. Don't mix and match paint because they'll react with each other. Don't ask me how I know. Cut all my stenciling out is with this Cricut join machine. It is a vinyl cutter and it's quite powerful and does a really slick job of cutting out labeling. So I'm going to use this smart vinyl, and it's the removable kind. You got to make sure you use the removable. So the stenciling's all done here. I weeded out all the lettering, place it on some transfer paper. I'll place them on the panel and on the chassis. I will then paint it with some black spray paint here. Let that dry for about an hour or two. Once it's kind of dry, we will take the needle here and we will peel off all the lettering, so it will reveal some gray lettering underneath a black paint job. Well, the chassis is finished and the paint has time to cure. I think it turned out pretty good. I'm really digging the matte black finish with the gray lettering. I think if I went with white, it would be too much contrast. The gray kind of gives us this muted industrial look, which is the look I'm going for. The chassis is all populated here. I found this old Bakelite knob in my parts bin. Not sure if I like it, but it'll do for now. And for the output transformers, I'm going to make some covers to hide those exposed leads, and I'll paint it gloss black, just like the power transformer there, so it matches. And then you can see the rear there. Everything turned out pretty awesome. So now it's time for the wiring. So when I wire an amplifier, I have a 5-step process I like to follow. So the first step will be to wire all the transformer carcasses to the safety ground. The second step would be to do all the ground bus work for all the tube sockets and the input and of course the B+. The third step would be to do the filament circuit and wire that up to all the tube sockets. Fourth step will be to run the AC line in on the switches. And then we can turn the transformer on and test the voltages, making sure everything is good with that. And once that's all good, then we can go ahead and wire all the passive components in. The hookup wire, I like to use 22 gauge solid core Teflon coated wire. This stuff is rated for 600 volts, so you want to make sure that you have the right voltage rating for your wire. I like to use red for all the B+ signal wire, and I like to use the black here for all the ground and bus work. So I got most of the wiring all done for the amplifier. The next step here is to verify the voltage coming out of the transformer and to make sure that everything is okay here, and because it makes it a lot easier to troubleshoot now than it is with all the components on. So what I'm going to do is set it to ohms, and I'll just see if there's any resistance in the heater circuit here, and there should be 1 or 2 ohms. So we don't have a direct short there, so everything seems to be wired good. So now the next step would be to actually turn the amplifier on. So I don't have anything component, so we're just going to be measuring the raw AC coming out of the transformer. So I have a current sink here, so a light bulb current sink. We're going to plug this in, and if there is a direct short or anything like that, that light bulb will light up. If not, then we should be fine. So let's turn it on. Now we can see the pilot light go on. Let's turn this to AC. Let's see what type of voltage we have there. So we have 13 volts AC. So that seemed to be within spec. And let's take a look at the actual heater circuit. So we got 6.2, 6.3 volts. So everything seems to work there. A few things before we start installing the components. I like to get my passing components from Mouser. They have a fantastic website, really good selection, and within 2 days of placing my order is at my door. I'm not sure how they do it. So to help with the noise rejection in the power supply, I'm going to add a choke. So this one is a triad. It is 10 Henry up to 90 milliamps, 270 ohms. So we're going to install that into the power supply section. Hopefully this will help cancel out any of the ripple. Output transformer, I'm going with the Edcore ones, but if you had trouble getting that in different parts of the world, I would recommend trying the Hammond. So this is 125 BSE. These are multi-tap, so you can get different types of primary and secondary impedances. The 125 BSE is rated for 5 watts, 45 milliamps. So this will just do for an EL84 amp. So amplifier is all completed, ready to do some testing here. As I mentioned, the choke was a bit of an afterthought, but it fits in there nicely. That's just the way some amplifiers builds go. So that's the power supply section, and that's the amplifier section. The only thing that I really deviated from was I redid this cable and put some shielded cable here for the heater supply to help with some more hum rejection. So when I'm doing the testing here, we're going to run everything through the light bulb current sink. I also have a digital voltmeter here that tells me what my incoming ball voltage is. If you want information about that, I'll put a link in the description below. We also want some shortening plugs, so we don't want to directly short the input. These plugs here have a 2K resistor in line with them, so we'll just put those in. And of course we'll want to run a dummy load. I'm just going to hook these up to the speakers. If you have an issue and you need to work on the amplifier, of course you want to drain the power supply capacitors. And I have this drain tool, so I'll put a link in the description below for that drain tool. I do have a draining resistor installed here, but that takes about a minute to drain, and sometimes I'm a little impatient, so I'll go ahead and just bridge everything with this. Alright, let's hook up the multimeter. One side up to ground. Hook the other side right on the B plus there on the first cap. Measure everything and we'll do our calculations to see what type of dissipation we have. Power there, and let's turn it on. Alright, so the voltage is going to spike up. So we got 308 volts, 307, 308 volts. So we'll just write that down. Okay, so we're going to remove the clip-on lead and we're going to replace it with an actual probe here. So with one hand in my pocket, let's probe some voltages. So the B plus again is 308, and we'll go to pin 7 of the EL84. That's 287. Pin 9 is 282. And then pin 3, which is the bias resistor. So that's 10.1 volts there. So let's switch over to the 1287. We'll go pin 6, which is the plate, and that's 169. And then we'll do pin 8, which is 1.76 volts of bias there. Alright, so let's crunch some numbers here and we'll calculate our current and our dissipation. So one more final testing I'm going to do here is see if there's any AC on the output. So let's just take a look at the B plus again, see what that's at. Down a little bit, that's okay. So let's switch it over to millivolts, AC millivolts. And let's probe 0. 0. Which makes sense because I have the speakers plugged in and I absolutely can hear no hum coming from the speakers. So this amplifier is dead quiet. So the amplifier is off. The RCA is from a tube preamp. So that's good. I have my iPhone with some royalty-free music on here, so don't get a royalty strike. On. Okay, so the voltage ramps back up again, so that's good. Let's turn the volume up. Awesome. So that seems to work. So I'm going to go ahead and put it through the paces and let's button everything up. So before we look at the schematic, guys, I'm going to mention there's really nothing unique with this amplifier circuit that I put together. The only thing really unique is the chassis itself. So this design is a hodgepodge of different schematics and different amplifiers that I've built over the year that I think would sound good to my ears. You may see some certain similarities between amplifier designs out there, and realistically, tubes have to operate within a certain parameters in order to make them sound good. Now, can you tweak the certain resistor values and the bias points? Yes, you may. And that's the fun thing about this hobby, that you can go in there and tweak until you think it sounds good to you. This is just a simple two-stage amplifier. The 12AT7 is the input stage and the EL84 is the output stage, and the two stages are capacitor coupled. The power transformer is sized for solid-state rectification. If you wanted to go with a tubed rectifier, you're going to have to get more B+ because of the voltage drop across the rectifier tube. I have AC on the filaments with 200 ohm resistors for virtual center tap. So I did run this through the Duncan Amps power supply simulator, and I did get the exact B+ voltage that I was expecting, and you could also see the current spike from the rectifier as expected. So the choke is installed right after the first filter cap, and it's part of the reason why this amplifier is so quiet. If you didn't want to use a choke, you could go with the 270 ohm resistor in its place, but you may hear some hum. So on the input, I'm using a 100K pot as a line level, and we have the 12AT7 biased at 3.5 milliamps, which falls right on the load line. Would 4 milliamps sound any better? I don't know, might be worth a try. And the EL84 is biased at 33 milliamps, which is 9.14 watts, which was well within its 12 watts maximum, so we're pretty safe there. So in this amplifier circuit, I do run some negative feedback, which is called plate-to-plate feedback, which takes a signal from the plate of the EL84 and puts it on the plate of the 12AT7. This pretty much takes the output transformer out of the equation of the feedback loop. I may employ some global feedback in the future, which takes a small bit of signal from the output and puts it onto the 12AT7. But it sounds pretty good as is. Let's take a look at how it's wired up. The incoming AC is neatly tucked up against the side here to the switch. The pilot light back again to standoffs that powers the transformer. The AC heater circuit comes out of here to another standoff, and then a shielded cable to the one EL84, the other EL84, and then to the 12AT7, avoiding everything, making sure we're not crossing over too many wires. And if I do cross over wires, I make sure that they are perpendicular to each other. I have the incoming signal tucked up on this corner. Everything is shielded and bonded, so there's no interference between the rest of the circuit. Keeps it nice and quiet. So the high voltage winding comes out of the transformer to the solid state rectification, two diodes, through the one power supply capacitor choke and the second power supply capacitor here. We have our bleeder resistor. Out of the last capacitor here, we have three wires. One wire goes directly to the one output transformer, the other wire goes directly to the other output transformer, and then the third wire goes up and feeds the input tube. So each channel of the input tube has its own power supply capacitor here, own electrolytic, and it runs on its own node, so to help separation between left and right, and to help separate from the output stage. So for grounding, I have a combination of separate grounding nodes and a star ground. So the power supply capacitor circuit here has its own separate ground, and it's a node that goes back to the star ground underneath here. The bias circuit for the EL84 has its own grounding node and goes back to the star ground as well. Each input tube has its own node on the ground on the negative side of the power supply capacitor, and it has a single wire that runs back to the star ground. So the left and right channel has its own wire that runs back to the ground. So for the safety ground here, all the transformers are bonded back to this point here, and that is all bonded back to the green wire safety ground from the incoming wall plug. This ground scheme works well. With the combination of the choke and the high capacitance I'm running here, this amplifier is dead quiet. Well, I've been listening to this amplifier for a couple days now, and it's been working flawlessly. I'm really happy with the way it turned out. Now, as compared to my 60N7 single-end trial amplifier, I find that the bass is punchier and deeper in this amplifier. Now, I feel that has something to do with the higher wattage and, of course, the negative feedback loop that this circuit has. I do find that the vocals are richer and more separated in this amplifier, but I suspect that has something to do with the constant current source on the input tube and, of course, that single-end triode magic. Now, I do plan to make a matching preamplifier for this amplifier. Please like and subscribe so you don't miss that build. Once again, thanks for watching, and we'll see you in the next video.